Since the dawn of time, humanity has gazed at the stars, seeking to unravel their mysteries. An insatiable thirst for knowledge has led us beyond the horizon, compelled us to conquer peaks and explore every corner of our home planet. And it is this very same innate curiosity that has carried us beyond the confines of Earth, into the cold and silent void of space. Today, I invite you on an incredible journey that will begin far from home, near the first probes that long ago left our solar system. Mentally blasting past the speed of light, we will hurtle past the most noteworthy stars in our cosmic neighborhood. Then, we will encounter a dying giant, Betelgeuse, from whose example we will witness how stellar evolution unfolds. Following this, we will get acquainted with the most solitary and mysterious objects in the universe, rogue planets. Finally, we will soar beyond the Milky Way to explore neighboring galaxies and reach the outermost limits of the observable cosmos. We won't merely graze its edges. Instead, we'll peer past the horizon to try and grasp just how truly vast our universe is. The journey will be long. Get ready, we're beginning. On April 15th, 2021, the New Horizons automated probe became the fifth human-made craft in history to travel 50 astronomical units from the Sun. 1 astronomical unit is the average distance from Earth to the Sun. Only the legendary Voyagers, and even earlier, the Pioneer 10 and Pioneer 11 probes reached this milestone. Most likely, none of these cosmic wanderers will ever return home. Some are still continuing their mission, while others have fallen silent forever. The New Horizons spacecraft is currently at a distance of 52 astronomical units from Earth and is moving away at a speed of 14 kilometers per second. Its primary target was Pluto and its moon Charon. Like many other interplanetary spacecraft, New Horizons performed a gravity assist maneuver near Jupiter. This acceleration not only allowed it to gain speed, but also to capture stunning images of the gas giant. The probe's cameras even captured for the first time a volcanic eruption on Jupiter's moon, Io. Having received this acceleration, the craft set off towards its main target. It reached Pluto's vicinity in January 2015. The mission involved a detailed study and photography of the dwarf planet and Charon, measuring magnetic fields, studying the atmosphere, and searching for new moons. Having completed its primary program, the probe did not cease its operations. It continued on into the Kuiper Belt, a region of icy bodies beyond Neptune's orbit, where it captured images of objects like Quaoar, Arrokoth, and others. Unfortunately, beginning in 2026, its radioisotope power source will start to deplete, and its instruments will shut down one by one. By the year 2038, at a distance of 100 astronomical units from the Sun, communication with it will most likely be lost forever. New Horizons will embark on an eternal journey along a hyperbolic orbit beyond our system. A similar fate also befell 2 other probes, Pioneer 10 and Pioneer 11. They became the first spacecraft that humanity sent into interstellar space. Pioneer 10, launched on March 3, 1972, was the first to reach Jupiter. It gifted us images of the gas giant and its moons, measured the composition of its atmosphere, and discovered that Jupiter radiates 2.5 times more heat than it receives from the Sun. These data formed the foundation of our understanding of the gas giants. Its twin brother, Pioneer 11, flew past Jupiter, but its primary goal was Saturn. Thanks to it, we gained data on the planet's magnetic field and numerous images of the giant itself, its rings, and its moons. Having completed their program, both probes continued on their journey. Alas, the last signal from Pioneer 10 was received in 2003, while the second craft fell silent back in 1995. Now they silently hurtle through the void, having forever left the solar system. But the spacecraft from the Voyager program flew the furthest of all. Voyager 1, launched on September 5, 1977, is today the most distant and fastest man-made object. It is currently 154 astronomical units away and is traveling at 17 kilometers per second. Its contribution to science is difficult to overstate. It discovered new moons and rings of Jupiter, captured images of volcanoes on Io, and revealed that the famous Great Red Spot is a giant storm. Voyager 1 has long since passed the Kuiper Belt and the heliopause, the boundary where the solar wind collides with interstellar gas. It provided scientists with unique data about the intricate structures born from this collision. Around the year 2025, its generators will finally run out. In 300 years, it will reach the inner boundary of the hypothetical Oort cloud, a vast sphere of icy bodies surrounding the solar system. To traverse it, it will need about 30,000 years. And then, another 10,000 years later, it will fly past at a distance of 1 7/10 light years from the star Gliese 445, to be lost completely in the depths of space. We also need to mention its twin brother, Voyager 2, which departed Earth on August 20th, 1977. Its destinations were Saturn, Uranus, and Neptune. It suggested the presence of subsurface oceans on Jupiter's moons, Ganymede and Europa. At Saturn, it measured the temperature and discovered new moons. But most importantly, it was the first in history to reach Uranus and Neptune, giving us unique photographs and discovering 17 new moons and ring systems around these icy giants. Currently, Voyager 2 has moved away from us by 128 astronomical units. In 42,000 years, it will approach the star Ross 248, and in approximately 300,000 years, it will fly past Sirius. Alas, spotting such a tiny object from Earth at such a distance will be impossible. We live at the dawn of space exploration, and these probes are merely humanity's first tentative steps. Perhaps someday, our distant descendants, having mastered interstellar travel technology, will bring them back to Earth as museum exhibits. But most likely, after millions of years, these fragile mechanisms, riddled with cosmic dust and radiation, will turn to dust that will dissolve without a trace into the infinite universe. Within 50 light-years of the Sun, there are about 1,500 star systems, and the total number of our stellar neighbors exceeds 2,000. Among them are both faint red dwarfs and the brightest giants. To tell you about each one would take an eternity. So now, we will travel at an unimaginable speed, far exceeding the speed of light, to see the most interesting worlds in our neighborhood. After making a pass by Proxima Centauri, we will instantly traverse 11 light-years and approach a red dwarf called Ross 128. Orbiting this unassuming star is one of the closest Earth-like exoplanets to us, Ross 128b. Unlike the closer yet cold Proxima Centauri b, this planet boasts moderate temperatures, ranging from -60 to +21 degrees Celsius. That is quite sufficient to sustain life. Its mass is approximately 35% greater than Earth's, which means the surface conditions could be very similar to ours. What's more, this system is headed our way, and in 79,000 years, it will be closer than Proxima Centauri. Venturing further, at 12 light-years from us, we'll find the star Tau Ceti. This red-orange dwarf boasts one of the largest planetary systems nearby. Scientists have discovered 4 objects here, 2 of which have already been recognized as exoplanets. One of them, Tau Ceti b, is a super-Earth and is located in the so-called habitable zone. It receives roughly as much light from its star as our own planet does, and its estimated surface temperature ranges from -18 to +19 degrees. This makes it one of the prime candidates in the search for extraterrestrial life. Now, let's journey 16 8/10 light-years from Earth to the star Altair. It's a bright, blue-white star, nearly 11 times brighter than the Sun, but its main feature is its incredible rotational speed. Altair spins once on its axis in less than 9 hours. This rapid spin has led to the star being significantly flattened at its poles, and its equatorial diameter is 22% larger than its polar diameter. Because of this, the temperature on its surface is uneven. The equator is noticeably colder and darker than the poles, superheated to 8,500 Kelvin. Let's continue our flight and reach the Fomalhaut system, located 25 light-years away from us. For a long time, the 3 stars of this system were considered independent objects, and it wasn't until 2013 that it was proven they are gravitationally bound. This is one of the most extensive star systems in our vicinity. The maximum distance between its components is 3 2/10 light-years. The brightest component is Fomalhaut A, a young, hot star, 16 times brighter than our Sun. The star is surrounded by a massive disk of gas and dust, where presumably planet formation is still underway. Our next destination is Arcturus, 37 light-years away from us. It's the 4th brightest star in the entire night sky, a true orange giant. Its life cycle is drawing to a close. Most of the hydrogen in its core has already burned out, and now it's slowly expanding, burning off the remnants of its fuel. Presumably, in the past, Arcturus resembled our Sun, but now its radius is 25 times that of the Sun. The same future awaits our star. But the most astonishing thing is that Arcturus is an outsider. It is part of a stellar stream, the remnants of a dwarf galaxy that the Milky Way swallowed up approximately 2 billion years ago. Very soon, by cosmic standards, this giant will shed its outer layers and transform into a white dwarf, destined for billions of years of slow cooling. In late 2019, astronomers reported a sharp drop in the brightness of the star Betelgeuse. In just a couple of months, its luminosity fell to 36% of its normal level. Some scientists predicted an imminent supernova explosion, which could have become the brightest object in the night sky. But by April 2020, the star had returned to its usual brightness. So, what happened? The data confirmed the hunch. The cause of the dimming was a giant cloud of dust that Betelgeuse ejected in our direction. To truly understand this event, we need to know what Betelgeuse actually is. It's a red supergiant, currently in the very last stages of its life. Its outer layers are incredibly unstable, perpetually pulsating and spewing millions of tons of superheated gas into space. The star's mass is approximately 17 solar masses, and its diameter is so vast that if you were to place it at the very center of our solar system, it would completely engulf all planets, extending all the way to Jupiter. Betelgeuse's luminosity is 90,000 times that of the Sun, and at its peak brightness, it reaches 150,000 times. Like any star, Betelgeuse was born from a gigantic cloud of interstellar gas. It spent millions of years in its main sequence phase, converting hydrogen into helium. But the more massive a star, the faster it burns through its fuel. Gradually, a helium core accumulated at its center. The star's subsequent fate depends on its mass. Stars whose mass does not exceed 20% of the Sun's never explode. They slowly transform into blue and then into white dwarfs. If a star's mass is comparable to the Sun's, then after the hydrogen in its core burns out, carbon fusion begins. The star swells up, transforming into a red giant. Eventually, it sheds its outer layers, leaving behind a hot white dwarf surrounded by a picturesque planetary nebula. But the evolution of massive stars, such as Betelgeuse, unfolds far more dramatically. When the core's mass exceeds a certain limit, gravity triumphs. The core collapses in a matter of seconds, pulling the outer layers in with it. A colossal burst of energy occurs. The core rebounds like a compressed spring, generating a powerful shock wave. This is a supernova explosion, an event of incredible power in whose flames heavy elements such as gold, lead, and uranium are forged. Left behind by the dead star is a tiny, yet incredibly dense object, a neutron star. If the initial mass was greater than 20 solar masses, then the core will collapse into a black hole. Fortunately for us, Earth is in no danger. Betelgeuse is too far away, and the gamma ray burst from its explosion won't be able to harm us. One day, it will flare up, for a short time becoming as bright as the full moon, and then fade away forever, leaving behind either a tiny neutron star or a black hole. Even in ancient times, people speculated that planet-sized objects, unbound to any star, could exist in space. Today, we call them orphan planets or rogue planets. Detecting such an object is incredibly difficult because it emits almost no light or heat. The first candidates were only discovered in the early 21st century. Some were found with the help of infrared telescopes, others thanks to the effect of gravitational microlensing. This is when a planet passes in front of a distant star, and its gravity momentarily distorts the light, acting like a cosmic lens. It's estimated that in the Milky Way alone, there could be as many as 100 billion such objects. The closest confirmed rogue planet to us is an object named WISE 0855, located 7 27 light-years away from us. It's a cool gas giant whose temperature ranges from -48 to -13 degrees Celsius. In its atmosphere, clouds of water ice have been discovered. How do such planets come into being? There are two main versions. In the first case, a planet forms in a regular star system, but then gravitational interactions with other celestial bodies throw it out into interstellar space. In the second case, it is born just like a star from a cloud of gas, but its mass proves insufficient to ignite thermonuclear reactions in its core. Could life exist on such a planet? Theoretically, yes. If a gas giant has a dense hydrogen atmosphere, it could serve as a reliable thermal insulator, retaining the heat of its hot core. In the lower reaches of such an atmosphere, temperatures could be sufficient to support liquid water. A rocky planet, flung out of its system, might also retain its heat. An icy layer on its surface and a heated interior could sustain a subsurface ocean. And if the planet has a moon, tidal forces would provide additional internal heating. Of course, for now, these are just theories, but even now projects are being developed, such as Cleopatra, which aims to purposefully search for rogue planets. Perhaps in the future, we will learn more about these lonely wanderers. A journey billions of years long awaits them through boundless emptiness and slow, irreversible cooling. Eventually, they will be swallowed by black holes or destroyed in cosmic cataclysms without ever revealing their secrets to humanity. The exact number of galaxies in the universe is unknown, but it's estimated that their count exceeds several hundred billion. They come in a wide variety of shapes: elliptical, spiral, irregular. Our galaxy, the Milky Way, is classified as a barred spiral galaxy. The masses of these stellar islands can reach incredible values, from dwarf galaxies weighing as much as 550,000 suns to supergiants thousands of times heavier than our Milky Way. Our galaxy, along with its closest neighbors, is part of a cluster called the Local Group. It includes more than 50 galaxies, 3 of which are relatively large: the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. The local group spans about 10 million light-years across, and its total mass exceeds that of the Sun by approximately 3 trillion times. In turn, the local group is just a small part of even grander structures. Our galaxy, the Milky Way, seems boundless to us, but on a cosmic scale, it's just one part of a vast family. Together with several dozen other star islands, it's part of the local group, which in turn is part of an even grander structure, the local sheet. Imagine a flat cloud of galaxies with a diameter of 23 million light-years and a thickness of about 5 million. And this local sheet is merely a speck within the gigantic Virgo supercluster, one of the key elements of the universe's large-scale structure. Scientists conventionally divide this entire colossal system, our local group, into 4 parts. The first is the Milky Way subgroup, consisting of our galaxy and its numerous satellites. These can be both dwarf galaxies and star clusters, forever bound to us by gravity. Our stellar home is a spiral galaxy, a giant disk with a diameter of about 200,000 light-years. And yet, its thickness is only about 1,000 light-years, making it resemble a thin disk. At the very heart of this disk lies a thickening, or a bulge, with a diameter of 27,000 light-years. It is believed that precisely there lurks a supermassive black hole with a mass of 4.3 million suns. And even that's not all. Around it, like a planet around a star, a smaller black hole orbits, with a mass ranging from 1,000 to 10,000 masses of the Sun. Meanwhile, the vast majority of the Milky Way's mass is made up of mysterious dark matter, making it currently impossible to accurately weigh our galaxy. According to the latest estimates, its mass is approximately 1.5 trillion times the mass of the Sun. If we pull back a little from our home, we'll see that the Milky Way has 31 satellites. These are mostly irregular dwarf galaxies, distorted by the powerful gravitational field of their giant neighbor. The nearest one can be found in the constellation Canis Major. It is located only 25,000 light-years from Earth. This dwarf galaxy, elongated into an elliptical shape, contains about 1 billion stars, predominantly red giants. Under the influence of the Milky Way's tidal forces, it has already nearly disintegrated. The stars ripped from it formed the gigantic Monoceros ring, a complex ring structure that encircles our galaxy. The largest satellite of the Milky Way, and the 4th largest galaxy in the local group, is the Large Magellanic Cloud. Its distance is approximately 163,000 light-years. It contains about 30 billion stars, and its diameter is merely 7 times smaller than that of our galaxy. But the cloud's mass is a staggering 300 times less than the Milky Way's. This enormous difference is simply explained. The Large Magellanic Cloud lacks a supermassive black hole at its center, while our galaxy is surrounded by an enormous halo of dark matter. Massive neighbors have almost erased its spiral arms with their gravitational pull, but the central bar is still clearly visible. The Large Magellanic Cloud is home to truly unique stars. For instance, R136a1 is the most massive of all discovered stars. This blue supergiant is 315 times more massive than the Sun, and its surface temperature exceeds 40,000 kelvins. Its brightness is 8 7/10 million times greater than the Sun's. Also located here is one of the largest stars in the studied universe, the red supergiant WOH-G 64. Its diameter exceeds that of the Sun by 1,500 times. According to current understanding, this star is in the final stage of its life, and within several thousand years, it will explode as a supernova. Continuing our journey, we will soon encounter the galaxy known as the Andromeda Nebula. Together with its satellite galaxies, it forms the second subgroup of the local group. It lies about 2.5 million light-years away, making it our closest large neighbor. Its diameter is about 220,000 light-years, just slightly larger than the Milky Way's. It contains approximately 1 trillion stars, which is 3 to 5 times more than in our own galaxy. Yet their masses are roughly equal, about 1.5 trillion solar masses. The thing is, the stars in the Andromeda galaxy are, on average, older and lighter. As our neighbor, Andromeda is one of the few galaxies that can be seen in the sky with the naked eye. It appears as an elongated, bright patch whose apparent diameter is 6 times greater than that of the full moon. A distinctive feature of Andromeda is its double nucleus. Through a telescope, one can observe 2 star clusters at its center, located 5 light-years apart. According to one theory, Andromeda once absorbed another galaxy, incorporating its nucleus. Another hypothesis suggests that the core is, in fact, single, but a part of it is hidden from us by a dust cloud. Andromeda has around 30 satellites. The brightest among them are the dwarf galaxies M32 and M110. According to some theories, several billion years ago, M32 literally rammed into the Andromeda galaxy, leaving a gigantic hole in its disk. However, the collision didn't leave M32 itself untouched. A significant portion of it was torn apart and transformed into Andromeda's stellar halo. И самое эпическое событие еще впереди. Примерно через 5 миллиардов лет Млечный Путь и галактика Андромеды столкнутся. Достоверно смоделировать последствия этой титанической встречи пока невозможно, но это точно будет незабываемое зрелище. Третий крупный участник местной группы – галактика Треугольника. Она вдвое меньше Млечного Пути и не имеет доказанных спутников. Ее диаметр составляет около 50 тысяч световых лет, а расстояние до нас – от 2,7 до 3 миллионов световых лет. Located within this galaxy is the NGC 604 Nebula, the largest known region of active star formation. This stellar nursery measures a staggering 1,300 light-years across. Compactly nestled within it are around 200 young, hot, hypergiant stars, whose powerful radiation causes the surrounding gas to glow brightly. Finally, the local group also encompasses other objects that cannot be assigned to any of the subgroups. Typically, these are distant dwarf galaxies that lack a strong gravitational bond with the giants. Among them, the galaxy IC10 stands out. It is unique in that a vigorous process of star formation is underway within it, and its immense hydrogen envelope rotates in the opposite direction compared to its stellar disk. Even the largest galaxies are just tiny specks in the boundless cosmos. The distances between them are immense, for even light travels millions of years to get from one to another. And yet, we can study them. The cosmos holds many mysteries, and each one is another step on the path to understanding the universe. Black holes are perhaps the most mysterious objects in the universe. To detect a celestial body that absorbs all light falling upon it is an incredibly difficult task. That's why today we know of not so many confirmed candidates. Nevertheless, mathematical models show that in our galaxy alone, their number could reach 100 million. That number seems immense, but if we consider that the Milky Way contains between 200 and 400 billion stars, it becomes clear. Black holes are fairly rare objects. To become a black hole, a progenitor star must possess a mass of at least 18 to 20 solar masses. Only in this case will a supernova explosion be powerful enough to compress its core into a super-dense clump of matter. As soon as this core collapses to the so-called Schwarzschild sphere, a point of no return, an object remains in the place of the collapsed star, whose internal structure can no longer be described by the laws of physics as we know them. One of the black holes closest to us is an object named a 0620-00. It is located at a distance of 3,500 light-years from Earth and is part of a binary system in the Monoceros constellation. Its companion is an orange dwarf, which every 7 75/100 hours completes a full orbit around its invisible neighbor. Calculations show that the mass of this hidden body is about 6 6/10 solar masses, which is too much for a neutron star. Which means the mysterious object is most likely a black hole. The gravitational pull of its more massive companion not only distorts the star, stretching it into an elongated shape, but also strips away its outer layers of material. These streams of superheated gas gradually flow towards the black hole, forming a bright accretion disk around it. It was the glow of this disk that led to the object's discovery. Contrary to popular belief, black holes don't just suck up everything in their path like some cosmic vacuum cleaner. Gravitationally speaking, at great distances, they behave just like a star of the same mass. So, a stable planetary system could very well exist around a black hole. There are several ways for its formation. First, planets could form from a gas and dust nebula left over after a supernova explosion. The black hole's hot accretion disk would warm them, and, hypothetically, life could even arise on such planets. Second, when a black hole captures and destroys another planetary system, some of its objects might survive and settle into stable orbits around their new host. In this scenario, an ice giant could transform into an ocean planet, while a gas giant could lose its atmosphere and become a so-called Chthonian planet. So far, such systems haven't been discovered, but there's no reason to consider them impossible. But if a planet gets too close, it faces an unenviable fate. The scorching accretion disk will strip away its atmosphere, and gravity will begin to pull it ever more strongly. Eventually, monstrous tidal forces will tear the planet into tiny pieces. Its fragments will continue to orbit within the disk, gradually dissolving into the hot gas until they are finally consumed by the black hole. It is believed that there are 3 main types of black holes in the universe. The first are supermassive black holes. They're found at the center of most galaxies, and their mass can reach several billion solar masses. They are born where the density of stars is very high. Massive stars burn out quickly, turn into black holes, which then merge with each other, forming gigantic objects. Their accretion disks shine so brightly that they're visible billions of light-years away. Such objects we call quasars. The second type is stellar mass black holes. They are far more common, but also harder to detect. They form from massive stars at the end of their life cycle. By absorbing matter, they gradually grow and can merge with each other, creating gravitational waves that distort space for many light-years around. The third type is hypothetical primordial black holes. Their existence is predicted by the Big Bang theory. Fluctuations in matter density in the universe's early stages could have led to their formation. Furthermore, the smaller such a black hole, the faster it evaporates, eventually transforming into an extremely powerful electromagnetic pulse. Calculations indicate that primordial black holes with a mass of about 1 trillion kilograms should be flaring up roughly around our present time. However, to date, not a single such event has been observed. Detecting such dark and compact objects is incredibly difficult. Некоторые из них выдают себя, вращаясь в паре со звездой и искажая ее орбиту. Другие можно заметить по характерному свечению их аккреционных дисков. Иногда удается получить даже изображение самого диска с черным пятном в центре. А в редких случаях помогает эффект гравитационного линзирования, когда черная дыра проходит между нами и далекой звездой, искажая ее свет. Нет никаких сомнений, что космос наполнен множеством темных и незаметных объектов. Среди них могут быть и странствующие черные дыры, таинственные объекты, блуждающие в межзвездном пространстве, которые навсегда останутся для нас невидимыми призраками Вселенной. Давайте отправимся в путешествие за пределы известного мира, начиная с нашего дома, Солнечной системы. Она включает в себя одну звезду, 8 планет и более 1 миллиона малых небесных тел. Самая дальняя из планет — Нептун. Радиус его орбиты составляет около 30 астрономических единиц, или примерно 4 световых часа. But this is just a tiny inner part of the solar system. The farthest discovered object, far, far out, is currently located at a distance of 132 astronomical units, or 18 light hours. And even that is far from the true boundaries of our system, the Oort cloud. Its inner reaches lie at a distance of 2,000 astronomical units, while its outer ones extend up to 1 light year. Here, the gravitational influence of our Sun ends, and boundless interstellar space begins. If we continue to journey further, then within 20 light years, we'll discover over 50 incredibly diverse stars, from faint brown dwarfs to bright and famous ones, such as Sirius or Altair. Some of them even have their own planets, potentially suitable for life. For example, the exoplanet Gliese 832c, located 16 light-years away from us, resembles Earth more than any planet in the solar system. But even to reach this world, which is, cosmically speaking, nearby, our fastest craft would have to travel for about 300,000 years. Our solar system, along with its neighbors, is part of the Orion Arm, a segment of the colossal Milky Way galaxy. It contains about 400 billion stars, which could be orbited by over 1 trillion exoplanets. Our galaxy's diameter spans 100,000 light-years, while its thickness is merely 1,000. The Milky Way, in turn, is part of the local group of galaxies, a cluster of more than 50 stellar systems within an area about 10 million light-years across. The largest among them are Andromeda, Triangulum, and our own Milky Way. But even this is just the beginning. The local group is part of the gigantic Virgo supercluster, which consists of more than 30,000 galaxies scattered across a space measuring 150 million light-years in diameter. Its total mass reaches 1 quadrillion solar masses, which is equivalent to 1,000 galaxies like our own. This supercluster, like many others, forms an even larger structure called Laniakea. It's an immense supercluster measuring 520 million light-years across. At its center lies the Great Attractor, a mysterious gravitational anomaly that pulls in all surrounding galaxies, including our own. We can't observe it directly. The Milky Way's disk gets in the way. Laniakea is just a node in the gigantic cosmic web consisting of galactic filaments, walls, and empty spaces, voids. Some of these structures are of unimaginable scale. The Hercules Corona Borealis. Great Wall stretches for 10 billion light-years. It is the most gigantic structure in the known universe. Its existence is a mystery to science, because according to current theories, something so enormous simply couldn't have formed during the universe's lifetime. And even this wall, which the human mind cannot fathom, is just a tiny fraction of the observable universe. Our universe is constantly expanding, and the farther an object is, the faster it recedes from us. At a certain distance, this speed surpasses the speed of light, and objects become invisible to us forever. This boundary defines our observable universe, also known as the metagalaxy, a sphere with a diameter of 93 billion light-years. We can only see and interact with what lies within it. But what lies beyond that horizon? This is a realm of hypotheses. Perhaps there are structures unknown to us out there whose gravitational pull we can sense but will never be able to see. One perspective suggests that beyond our universe, there is neither time nor space as we conventionally understand them. It's possible our metagalaxy is merely a fragment of an even more intricate cosmic superstructure nestled within multidimensional space. Another concept is the multiverse, akin to a foam made of countless bubbles. Each bubble represents a distinct universe, complete with its own unique set of physical laws. The most radical hypotheses, however, even go so far as to suggest that our world is nothing more than a simulation, much like a computer game of incredible complexity. Of course, cosmic distances are astounding and even frightening. But what is even more amazing is that humanity, a tiny creature on a speck of dust orbiting an ordinary star, is capable of creating technologies to gaze into these abysses. Every single day brings us new discoveries, moving science forward step by step, which means many more fascinating journeys await us, right to the very frontiers of knowledge.